we have a quadratic equation here, which you can see because there's a squared in it, right? And we're going to solve this thing by square rooting both sides. We're not ready for that yet, but I know we're going to use the square root principle because you can see where are all the x's, or in this case the k's. They're all inside this single squared. And if I can get that thing in the red box by itself, then I can square root both sides and it'll practically be done. So I need to do a little work on this thing before it's ready for a square root. Remember the square needs to be isolated. So I'm going to say minus 2 from both sides. And let's write that over here where I have a little more space. That's going to be negative 9 times the 9k minus 3 squared. And it's going to be equal to negative 324. Okay, now I divide both sides by 9. Right, divide by negative 9, divide by negative 9. This will get the square, the perfect square by itself. So it's going to be 9k minus 3 squared on the left. That's what I want. And now this thing over here on the right by itself, which I forgot my calculator, so hold on just a second. This is going to be 324, 108, 33, 36. I think it's going to be 36. Okay, great. So I take that and I put it right here. And that's my answer to the first part. That's called isolating the square. And the reason we call it isolating the square is because if you ask, what's the square? Well, the square is the thing being squared. Now it's by itself. And now we can get at it with the square root symbol. So in the next step, what I'm going to do is use the square root principle to square root both sides. That's like drawing a big old square root on both sides. You just have to remember that it's a little bit different because I'm going to make two equations. One's the plus version, one's the minus version. So over here on the left, I'm going to put my plus version. This is 9k minus 3 equals, well, what's the square root of 36? I mean, in this problem, this turns out pretty nice. 36, if you remember, factors into 6 and 6. So what I'm really looking at here is the square root of 6 times 6. And because those are the same number, they pop out. And this becomes 6 times square root nothing. So we don't even need the square root anymore. Okay, well, that's really nice. It won't always be that nice. Sometimes you might get an imaginary, or sometimes you might get some irrational number which has a radical left over and won't go anywhere. So you just work with it best you can. This one turns out to be nice. On the right side of this equal sign, I get 6. Now in the other equation, it's going to be very similar. It's 9k minus 3. But because it's a plus or a minus square root, right? Burn that into your brains. Plus or minus square root. This is going to be a minus 6 over here. And now how do we solve these things? Well, you have to set them up as two different equations. So let me clear some space. And I'm going to make two equations. One of them is 9k minus 3 equals 6. So we add 3 to each side. We divide both sides by 9. And I get this as one of my answers. Okay, that's just the number 1. The other one, which is going to be very similar, but I have that negative 6 to start with. It's 9k minus 3 equals negative 6. Now you add 3 to both sides, and you get negative 3. And now you divide both sides by 9, and you get negative 3 over 9. Remember to simplify these things, because if you write negative 3 over 9, you're probably losing a little credit for that. You want to write negative 1/3. Okay, so that would be my second answer, negative 1/3. So again, sometimes these will turn out to be nice numbers, like the number 1. That was great. Sometimes they'll be fractions. Sometimes they'll have square roots. Sometimes they'll have imaginary numbers in them. So you just got to watch out and be flexible for anything.